Well, hello, ladies and gentlemen. This is Mr. Green, and we're starting our Unit 3, which is actually Unit 2 in the coursework. But don't be confused by all that. It's just leave that to me to be confused. It is Unit 2 this week, and or you should be finishing the stuff that says Unit 2 in the course, taking the unit tests, so forth, things like that. And we'll be starting Unit 3. Unit 3 talks about normality, normal. Hmm. Well, let's see here. Before I get into that just too deeply, a little word about due dates. We are approaching the time where I'm starting to put in and locking down things. So if you have not completed the stuff in the first unit, it will be locked down and you will get the grade that is out there. If you're a late starter and that stuff was exempted from you, don't worry about it. It's exempted. Don't have to worry about that. If there's a zero out there, the zero can get locked down after 28 days. So you want to make certain you've got those taken care of before that 28th day. Okay? So, what is normal? Let's define it a little bit. The definition of normal. Well, if you watch the lessons that they're giving you in the course itself, they start talking about normal distributions. They start looking at some graphs and things like that. And what you're looking at there is any time that you've got your mean and your median and your mode are all at the same location in the center there, and you've got even distributions on both sides of it, that is a normal distribution. Now, they don't go into just a whole lot, and there is not a real technical definition of what a normal distribution is, because normal is something that we're going to want to use. So we don't want to get it so precise that we can't we can't use what we know about normality, because one of the things that they're going to show you in normality is the fact that we can actually break it down, and we can say that such a percentage of them is on one point and such a percentage is at another point, and those percentages are things that we want to be able to use. Okay, so here's this normal mean mode median here, and then we can look at it as the percentages. Well, why can we look at it as the percentages? Because this little sigma right here is a lowercase sigma, lowercase summation sign. Yeah, lowercase letters in Greek. Who figured? Okay, the bigger the number, like this one right here, the flatter the line, the normal line is. Okay, the smaller the number, the taller, the skinnier the normal line is. Okay, so it works kind of like dress sizes. Small numbers, skinny. Big numbers, fat. Okay? So it works kind of that same way. But it's showing you how that normal line works. There is not a single normal curve that you can look at and say, all the curves look like this. Well, they all look that bell shape in a sense, but they don't all have the same amplitude. They don't all have that same height that they go to. And it's based upon that sigma. However many sigmas, it's always 6. There's always 6 sigmas in there. That's what the way the sigma is calculated. But there's always 6 of them in there, and it's showing you percentages. Okay? So if you're 1 sigma away, you're 68% of the responses are 1 sigma from that mean. That's what that means. There's a rule about that. It's called the empirical rule. Look it up. You'll find it. We'll talk about it in the lessons. It's right here. 68%, 1 sigma away from the mean. Okay? So that means that 68% of the responses are in this light gray area. If we look at the little bit darker gray area from here to here, we're talking about 2 sigmas away from the mean. And if you look at that distance, you're talking about 95% of the respondents are in that area. If you're talking about this dark gray area, this is the ends, the very far tails, and you're talking about 97.5% of the population, of the responses, are in this darker gray area. That's what we mean by a normal distribution. One that is evenly spread out like that, and one that has the mean, the mode, and the median all be at the same location. Okay? Having said that, I think you are probably ready for some standard deviation calculations. Now, we did this last time, didn't we? We had this formula last time. So where did this formula come from? Remember, we were summing up. We were taking the sum of the mean, or the current number minus the mean. That's what we were doing. The current uh, value that we're looking at minus the mean of all the values. We're squaring them and summing them all up, and then dividing by n minus 1. And that's equal to s squared. S squared. How does that relate? Well, that is the number that is actually very, very close to the sigma number. If you were looking at a particular sample, that would be the sigma of that sample. Okay? Well, it's not really sigma. It's sigma squared of that sample. So, I want to show you something. I've got my little handy dandy calculator right here, and in my stats area I have got some numbers. Not a lot, just L1, L2, just a couple of numbers. What I'm going to do is I'm going to press stats, and I'm going to go over here to press to test, and I'm going to come down and do that this one. What am I missing here? Oh, is it under list? Yeah, list, math. Nope. Okay, pause. Okay, sometimes old men have brain farts. You have to think about it for a couple of seconds. Well, it just walked out on me there for a second. I had to get my mind back around what I was wanting to say. What I wanted to show you here was I'm going into stats, and I'm going to go over here to calculate, and I want to look at number 1, the one variable statistics. That's what we're looking at. It's just one variable statistics. It didn't matter which list I'm using, list 1 or list 2. So I'm just going to press enter on that, and I'm going to hit calculate so that it calculates it out. This x bar, that is the mean of the sample that I'm looking at. Okay? The sigma of x, that's the sum of all the numbers that I had out there. This sigma of x squared, that's just x squared summed up, right? You see this sx right here and this sigma x? Those are the numbers for the standard deviation of the sample and the standard deviation of the entire body, if this was an entire population that we were looking at. Now, just to show you what this is if I go down here a little bit further, you're seeing the Q1, the median, the Q3, and the maximum. These are the numbers that are used for the box plot, aren't they? These are the one variable statistics. And you've got the mean and you've got the sigma on here. Well, that's very nice. That's what these are here. That's what this S squared is. Well, that S that was on that calculator was the same S that's sitting right here. Okay? This is one of the first equations that you've got that's on your equation chart that you see at the end of your test and that you're going to be using on the AP test. This is one of them. Okay? You can see you can get this right off that 5-point summary. So it's really easy to use that 5-point summary to get that information. This is telling you how far it's spread out. If it's a normal distribution, you can be able to use this and the empirical rule to know some percentages. Okay? So, not taking attendance during these recordings. Remember, I've still got quite a few students, and they're giving me a little bit of a relief, but still with quite a few people in my classes. You need to make certain you're telling me you're in AP Stats when you send me a communication. That way I can find you really, really quickly. Otherwise, I get lost, can't find where I'm at. So, I appreciate it, and I'll talk to you next